We have been discussing about various post-harvest operations from the beginning, right? There is one basic post-harvest operations which we commonly use in everyday activity. What is that? To extend the shelf life or to retain the quality of the food materials, especially fresh commodities. It may be a fruits and vegetable, or it may be fresh meat product, milk product, or any fresh commodities. We mostly rely on a efficient cold chain to maintain the quality and reduce spoilage of fresh agriculture commodity. So in this lecture, we will see some of the important aspects about the cold chain management activities and then cold chain gadgets available to maintain the commodity under reduced temperature, and some of the softwares, cold chain related softwares available to enhance the safety, food safety and quality of the food materials. So in this content, we will discuss about importance of cold chain management, components of a cold chain, a physiology of a perishable product, and effect of cold chain on quality of the perishable commodities, cold chain gadgets, and the recent IoT and blockchain technology for cold chain. So in India, 1/3 of horticulture produce, especially fruits and vegetables, are wasted every year. As you all know, from the beginning, like even 10 years back, it was like 30%. Again, before even 20 years before, it was 30% to 40% of horticulture commodities. We are improving our facilities, especially cold chain facilities, infrastructure facilities related to agriculture commodity storage and distribution and supply chain. Still, we are facing a very big losses, a very big portion, 1/3 of a horticulture commodity which we produce is lost. India is already a self-sufficient in agriculture practices. We are producing sufficient enough to feed the entire country. Moreover, we are producing surplus which we can export to other countries, especially fruits and vegetables, grains, meat and dairy products, fish and fish-based products. So million across the country suffers from malnutrition. Like even though we are producing sufficiently, still children in India are facing malnutrition. And you can see in 2020, the global hunger index score of India is 28.5 in 2020, and it has 15.2% undernourished population in India. So there are, we can say, so many things related to the malnutrition and nutritional malnourished children, and in unavailability of nutritious food for the Indian population. So the global cold chain logistic market is a very vast and valued at 159 billion in 2020, and it is expected to reach at 585 billion by 2026. So there is a very big investment coming into the infrastructure development, like it may be construction of cold chain facilities. Like India, we are identifying the district level farmer producer group, and we are clustering them, and we are constructing cold chain facilities or any other facilities like pack house facilities, which is required for a area specific development. Area specific infrastructure developments are going on. That is why you can see there is a huge investment and there is a huge value of cold chain coming in India, and it is estimated an annual value loss of agri produce in 2022. If you see the data available from the 2022, nearly 92,000 crores of rupees is lost due to insufficient cold chain and insufficient post-harvest gadgets in our country. Out of this perishable product like fruits and vegetables, meat, fish and milk, which accounts an estimated loss of 50,000, almost 50,473 crores of rupees is lost, especially in case of fresh commodities, where the perishable commodities which have very low shelf life, and there is only way to minimize the post-harvest losses in case of perishable is immediately bringing them into a cold chain. Cold chain in the sense uninterrupted cold chain is recommended right from the harvest until it reaches the end consumer. So reducing the post-harvest food loss at least 15% from the current value of 30% could provide 18.3 million ton of fresh food each year, which is valued at 3.9 billion. Okay, so you can see cold chain sector, which holds the key for addressing this existing food loss problem in our country, directly by increasing the shelf life of the food and indirectly by reducing the reach of food to the market and processing facilities, right? Still, by establishing a well connected cold chain facilities, a particular crop, the value of particular crop can be increased double, or the farmer's income can be doubled. If you see a grapes which is selling in India for 80 rupees per kg, 80 rupees per kg, if it is exported to a Middle East country where we can get more than 250 rupees per kg, in such case cold chain holds the key in extending the shelf life, extending the market reach of a particular commodity. So what is cold chain? The cold chain is a temperature controlled supply chain. We have an existing supply chain for all the commodities in India, like we have onion. We have a well established supply chain for onion and potato, which are a staple food for Indians. More or less throughout the year, we try to maintain the price of the potato and onion in a similar range, right? So already there is a supply chain which exists, which involves a lot of middlemen, vendors, distributors, stockholders. So if the existing supply chain of a particular commodity is replaced with a temperature controlled system, in a temperature controlled supply chain, it is called as a cold chain system. Okay, so an unbroken cold chain is an uninterrupted series of refrigerated production, like storage, distribution. Once you harvest from the mother plant, it has to be immediately, the temperature of the commodity has to be reduced, or the field heat which is there within the commodity has to be removed first. That we call it as a pre-cooling process. So after cooling, it is transported to a pack house or a cold storage, and then in a refrigerated transport it is transported to a retail outlet, or through an air cargo or a ship cargo it is exported to other countries for retailing and distribution. So this kind of temperature controlled distribution system will help us in lowering the it helps us in distributing this temperature control system. It is used to preserve and extend and ensure the shelf life of the products such as fresh agriculture commodities, seafoods and frozen foods. So cold chain provide the following benefits for perishable food materials. It reduces the respiration. You know the metabolic rate of a commodity, agriculture commodities, reduces when you reduce the temperature of storage. Similarly, the cold chain reduces the respiration. Once the basic metabolic activity, respiration, is reduced, it reduces all other metabolic changes which is occurring within the commodity, and it reduces transpiration. It reduces the water loss. It reduces shrinkage of commodity, and then ethylene production. You know, the ethylene production is one of the end product of a metabolism which is taking place within the food materials. So once the ethylene production is minimized, it slows down the respiration. So the respiration rate and this ethylene activities are interdependent. When we address one respiration issue, Again, the respiration rate will also reduce the ethylene production, thereby the ripening is delayed. And then increase resistance to the ethylene action, decrease activity of microbial decay in case of fruits, and reduce browning and loss in texture, loss in flavor, and other nutrients. Okay, so you can see field storage from the field, when it is harvested, when it is shipped, until it is reaching an end consumer or the end kitchen or the end user table, it has to be maintained under the low temperature. That is called the cold chain. The components of cold chain. If I ask you what are the components of cold chain, everyone will tell cold storage is a. In our country, we see the cold chain starts from the cold storage. Right, there is no other interventions available for reducing the temperature of the commodity, whereas the efficient cold chain begins from pre-cooling operation. Pre-cooling is the one of the key which holds the key for enhancing the shelf life or extending the shelf life of a fresh commodity. So pre-cooling is nothing, it is removal of field heat. Immediately after harvesting, detaching the fruit from the mother plant, it remains at the higher temperature like 28, 30 degrees Celsius. From 30 degrees Celsius, it has to be brought to a minimum safe storage temperature of 2 degrees Celsius or 4 degrees Celsius, depends upon the commodity. So pre-cooling is performed on the farm itself, that too within a short duration of time. Short duration of the time in the sense 3 hours to 4 hours. Within 2 hours to 3 hours, if you can able to reduce the metabolic activity, it initially reduces the respiration rate and it also reduces the ethylene production. But what we do in our condition, Indian condition, is we allow the commodity to respire. We store it under the open field itself. It increases the respiration rate and it increases the ethylene rate. Once the ethylene activity is increased, then it will be in a multiple fold. It is exponential increase. Right, one molecule of ethylene will trigger autocatalytic production of ethylene in the fruits and vegetables, and it is a exponential increase in growth. So once after ethylene production starts, if you are minimizing the temperature or if you are reducing the temperature, then there is no use. So it should be starts with the pre-cooling and then packing and cooling fresh food product. Like food processing, you can see freezing of certain processed food materials, and then cold storage. Cold storage, there are long-term cold storage, short-term cold storage, or you can see there are different types of cold storage for different types of commodity. We have cold chain for dried red chili. We have cold chain for a fresh apple. We have a cold chain for frozen foods. So the temperature which we maintain, the temperature and relative humidity conditions which we maintain differs from commodity to commodity. And then distribution, even during distribution, cold transport, temporary warehouse under temperature controlled conditions. Marketing, like refrigerated container, refrigerated display racks, refrigerated marketplace. So these are some of the component which helps us in maintaining the temperature of the commodity under low temperature. So first, as I said, pre-cooling, and then the pre-cooling which reduces the field temperature of a fresh horticulture commodity. The target temperature depends upon the type of commodity, and then our pack house facilities. In pack house we have various operations like sorting, grading, washing, drying, packing, even waxing, wax coating. So all those things are performed in pack house operations. In a modern pack house operations, it starts with pre-cooling and then grading, proper grading based on the ripening stage, and then some pre-treatment, pre-storage treatment like waxing are done in the pre-cooling in the pack house systems. And we have different types of pre-cooling systems. Small scale, in farm level, we have mechanical pre-cooling technologies like portable forced air cooling systems, or packing with ice will also helps us in reducing the field heat. And the non-mechanical type, we have a portable evaporative forced air cooling systems, and in large scale we have vacuum cooling, hydro cooling, forced air cooling system. forced air wall cooling systems, and then non-mechanical, when you pack with dip it in a ice slurry, will also help us in reducing the temperature immediately after harvest. So that is this where we have this, where we don't have these pre-cooling facilities. We recommend the farmers to harvest at the early morning, like the fruits and vegetables. We recommend it to harvest at the early morning stage, because early morning temperatures will be lower. So if you harvest, the commodity will be under low temperature, or the refrigeration load required to reduce that field heat will be reduced. So current scenario in our country is there is no pre-cooling operations or on-farm storage operations. Immediately it is, after harvest, it is brought to a nearby market, or it is sold to a vendor where he procure in bulk, and then he take it to a commodity, multi-commodity storage, where the temperature is not a product specific, it is a region specific, right? So principle of half cooling time. The literature says immediately after harvest, within 3 to 4 hours from harvest, the temperature of the commodity should be brought to like 7 by 8 cooling time, right? So initially if the product shows 25 degrees Celsius, the temperature has to reduce to below 5 degrees Celsius within 6 hours of time. Then the potentially the particular product, a particular batch of product, will have a longer shelf life in the market. So the rate of cooling of produce is also one of the major factors which we have to look into when we are performing the cooling process. Like cooling a commodity is a heat and mass transfer operation. When you allow air, when you are forcing air to pass over the surface of the fruits and vegetables, what we are doing, we are reducing the temperature, and then the heat transfer occurring between this forced air and the product is conventional heat transfer. So what happens here, it doesn't alone reduce the temperature, it also remove moisture from that. So if you are keeping it for a longer period of time under a forced circulation, easily the product loses its weight, the transpiration occurs, and easily the product gets shrink. So that is why we have to make a calculated temperature decrease in the product. So within a shorter period of time, we should be able to reduce the temperature to 7 by 8 cooling time. So that is a half cooling time. So half cooling time should be shorter to reduce or to avoid shrinkage in the commodity. So the rate of heat transfer depends upon the cooling medium. Mostly we rely on air cooling, or in some case we have hydro cooling. So the temperature of the air or the temperature of the water or the delta T, the temperature difference between the product and the temperature, should be maintained in such a way that it reduces faster. The rate of cooling is faster, and then the difference, the temperature between the produce and the cooling time, the nature of cooling medium. Moist air will help us to retain the arrest the transpiration problem or the water loss problem. Okay, so if the temperature, if it is a dry air, it tends to remove more moisture very quickly than the moist air. Now cold chain logistic. In global market, the cold chain logistic play an important role in food safety and food waste. So the perishable food, including fresh fruits, vegetables, dairy product, meat and fish products, need to be maintained at a low temperature or under frozen state throughout the entire supply chain. So cold chain logistics provide facilities for transformation of processing and goods, as well as ensuring this safety and sanitized condition. So this farm to fork transportation is essential in case of frozen food materials. A vast global transportation network is required in it, which includes the manufacturer, supplier, warehouse, retailers and consumers. All means of transported should be brought under reduced temperature or under cold chain. So you can say the cold chain, you can see different types of cold chain. Frozen, minus 18 degrees Celsius, the frozen ingredients, processed foods, and then the fruits and vegetables, ice cream and frozen meats, are transported under the reduced cold chain temperature of minus 18 degrees Celsius. This is frozen food cold chain temperature. Chilled cold chain, that is 0 to 10 degrees Celsius, most of the fresh commodities, right from fresh fruits, vegetables, fresh meat, milk, butter. Mild chilled cold chain, like 10 degrees Celsius to 20 degrees Celsius. Subtropical fruits. Subtropical fruits like we can say our onion, red chili, even tamarind is transported under reduced conditions. So there are so many other products which is coming under this mild chill cold chain, and normal cold chain is reduced less than 20 degrees Celsius. Whole onion, dehydrated food, pickled jam, processed foods are transported under this about 20 degrees Celsius. Now, so far we have discussed about this what is this cold chain, what are the gadgets available for cold chain, and how the temperature is maintained under low temperature, what are the important cold chain operation will need to be addressed. Now we'll see some of the basic principles for increasing the shelf life of a perishable commodity. First of all, the fresh fruits and vegetable, what we are talking about, right? The fresh commodities, fresh fruit, vegetables, flower, or any other plant part is a living tissue that are subjected to continuous changes after harvest, right? Some of the changes are desirable, but most of them are not desirable changes, right? Ripening is a desirable changes. So once you harvest, if a fruit ripen after harvest, that's a desirable change that we can expect. Or when you are about to consume the fruit, it ripes on the way from harvested end to the end consumers. There are commodity which are harvested before ripening and it is ripened after harvest. For example, our banana, and we have our papaya, right? If it is papaya, if it is harvested at the complete ripened stage, transportation become very difficult. In such case, we harvest it in a unripened state and we allow it to ripen during the transportation. So there are some of the desirable changes, but most of the changes are undesirable. The main goal of post-harvest cold chain, the main aim of post-harvest cold chain management is to slow down these changes, right? Or not only the cold chain, whatever post-harvest interventions you pinpoint, it will aim at minimizing the metabolic changes associated with the freshly harvested commodity. For example, we have wax coating. We aim reduced respiration, and we retain the freshness of the commodity. Or it may be an edible coating, or it may be a packing, or it may be any kind of post-harvest interventions. Most of the post-harvest interventions we can see it aims as minimizing this metabolic changes after harvest. So after harvest, fruits and vegetables are detached from the mother plant and it do not enjoy any more supply of water or nutrients from the mother plant. Until it is detached from the mother plant, it has continuous supply of nutrients. Therefore, after harvest, the fruits and vegetables depends upon its own carbon reserve for respiration. So after harvest, the fruits and vegetable depends on its own carbon and water reserve, which makes this commodity more perishable. Okay, if the commodity respires higher, it is more perishable. It consumes its own reserve in a faster rate and it depletes itself. So they loses the water and dry matter content as the result of respiration and other metabolic activity. So fresh produce are derived in very diverse in case of morphological structure. There are root vegetables, there are some asparagus like stem, we consume the stem as a vegetable, leaf as a vegetable, flower as a vegetable, or fruits as a edible portion. So in composition or in morphological structure, morphological character, these portions, these particular fruits and vegetables differ. So if you see, therefore the cold chain requirement is also vary among the commodity. For there are some frozen, poultry and meat product where we need minus 25 degrees Celsius, or frozen foods minus 20 degrees Celsius, dairy products 2 to 1.5 degrees Celsius, and then low temperature apple, strawberry, carrot, lettuce, where the respiration rate is lower, we can go for 0 to 2 degrees Celsius or even 12 to 16 degrees Celsius. Right, it depends on the commodity, the nature of the commodity which we are about to store. So horticulture products can be classified according to their respiration rate. Low respiring, very low respiring, moderate respiring, high, very high and extremely high respiring commodity. If a particular commodity produce 5 to 10 milligram of CO2 per hour per kg at a temperature of 5 degrees Celsius, we can categorize under low respiring commodity, right? Very low is less than 5 milligram of CO2 per hour per kg at a temperature of 5 degrees Celsius. So you note that this temperature has a major role in determining the rate of respiration. If it is 5 degrees Celsius, means it is reduced to respiration. If it is 30 degrees Celsius, it will be higher, the rate of respiration will be higher. So you can see commodity, low respiring commodity, mostly you can see the dormant stage of fruits and vegetables, or storage part, garlic, onion. So this comes under bulbs and tubers comes under this very low respiring. Moderate respiring, we have tropical fruits. High respiring, the commodities which are harvested in the active growth stage, sleek, lettuce, most of the leafy vegetables which is harvested in the active growth phase. And then we have extremely high respiring asparagus, mushroom, parsley, peas. So there are some of the extremely high respiring commodity. Now according to the respiration behavior, during maturation and ripening, fruits are classified either climatic and non-climatic. These climatic fruits shows a larger increase in the respiration and ethylene production during ripening. Okay, so this classification is very important for determining any post-harvest operations. Either it is climatic fruit or non-climatic fruit. In our condition, the thumb rule is, if it is a non-climatic fruit, we never bother about the post-harvest handling techniques. It as such by itself, it takes care of its storage and it stays in the market sufficient time. So we don't perform or we don't give any post-harvest interventions except packing and distributions. Whereas the climatic fruit, right, the climatic fruit is very difficult to extend the shelf life because it shows a larger increase in respiration and ethylene production after harvest. So after harvest, it enters into a autocatalytic production of ethylene, which makes it more perishable. Okay. So this is the difference between, I can explain more well using this particular graph, climatic and non-climatic fruit. So as I said, the respiration rate, CO2 production per kg per hour, right? So all the fruits, even if it is a climatic fruit or non-climatic fruit, immediately after harvest, this is the point where it is detached from the mother plant. Okay, so it has a pre-climatic minimum, like pre-climatic declination. You can see it declines, the respiration rate declines both in climatic as well as in non-climatic. The only difference is after a certain period of time, like this particular declination is due to shock. When it is detached from the mother plant, it was continuously enjoying the water supply, nutrient supply from the mother plant. Suddenly it is detached from the mother plant. In a harvesting shock, will be a pre-climatic minimum, like the temperature reduces or the respiration rate reduces for a particular period of time. For example, you can see in our case, like mostly it is 4 to 8 hours. The 4 to 8 hours, it depends upon the commodity again. So this pre-climatic minimum, the pre-climatic declination continues as such in case of non-climatic fruits. It doesn't respire again. the respiration rate keeps on reducing in case of non-climatic fruit. You can see non-climatic fruit, the respiration rate keeps on decreasing, whereas the climatic fruit, it rises immediately after harvest. Sometimes, no, after 4 hours, let us assume after 4 hours it rises to a climatic peak, and then it declines after some time once it is completely matured, or we can say once it completely utilized all its metabolic reserve. There comes a post climatic declination where the respiration rate decreases by itself. Now the magnitude of respiration makes it high respiring, low respiring, moderate respiring within climatic fruit. So climatic fruit will have this curved metabolic rate, the curved respiration rate. You can see apple is stored for a longer time, right, without any much without many post-harvest interventions. It is stored for 6 months just by reducing the temperature. But it is also a climatic fruit. You can see initially the respiration rate decreases and then the respiration rate increases. But the intensity or the magnitude of respiration matters. So the maximum respiration rate is less than 10 milligram of CO2 per kg per hour, whereas, or ml of CO2, here it is less than 10 ml of CO2 per kg per hour, whereas in case of banana, immediately there is a steady increase in respiration rate, and the respiration rate reaches more than 35 ml of CO2 per kg per hour. When still in avocado, it is even more. It reaches more than 60 ml of CO2 per kg per hour. So this intensity of respiration decides whether it can be stored longer in a market, or whether it requires a severe post-harvest interventions, or it requires a less post-harvest interventions. So apple, if I see apple, only a small wax coating and then cold chain will help it store it for a year together, like throughout the year. Whereas whatever severe post-harvest interventions we give to banana, it cannot last more than 30 days, right? Similarly, avocado, whatever severe post-harvest interventions we go for coating, edible coating or wax coating, you reduce the temperature, you add ethylene blockers, you prevent it from contact of ethylene, still you cannot store it beyond 3 months. So that is the post-harvest interventions. The level of severity of post-harvest interventions required is based on the magnitude of respiration of the commodity. As I said, this is the changes associated with color changes associated with the climatic fruit. So when there is initially, you can see this is 10 milligram of CO2 per kg per hour. Initially it reduces, it is harvested from the mother plant, and you can see there is no respiration rate. Here it is respiration rate decreases, and then the respiration rate increases with respect to time, and you can see the associated color change. And once the metabolic reserves are completely utilized, we have a post-climatic declination. So this is climatic peak, and this is post-climatic declination, and this is climatic rise. This is climatic rise. Similarly, in case of tomato, in case of banana, you can see it will remain green within 1 hour or within 1.5 hours. You can see it turn green color to yellow color immediately. So this color change or these metabolic changes are very faster in case of tropical fruits. Here, this is another graph, an interesting graph where we can see all the series of changes taking place during ripening. So this is the point. Let us assume this is the point we are harvesting a green matured banana, green mature tomato. So you can see the number of stages like 0 day harvesting, and first day, second day, third day, up to 8th day. So in 8th day it became from green mature green to ripened red. It became ripened red in 8 days. In between we have a breaker stage where the green color breaks into a pearl red color or pearl yellowish red color, and then turning stage, green turn into red color or pink color, and we have a light red and dark red, a ripened red stage. Now, as I said, the basic metabolic activity, respiration, ml of CO2 produced per kg per hour. So initially the respiration rate, there is no, when it is harvested, there is no much higher respiration rate, and when the climatic rise, you can see the maximum respiration rate, and then it declines. The ethylene production and then the respiration rate go hand in hand. When the respiration rate increases, the ethylene rate also increases. Okay, so this is one of the point we should note down. The respiration rate increases along with the ethylene production, vice versa. Ethylene in turn also triggers the respiration rate. And then we have total soluble solid contents, soluble solid concentration declining from harvest, and it is associated with the changes in the conversion of complex sugar, like conversion of starch into simple sugars. So the starch percentage is also declining. And then the color change. We know the chlorophyll pigment declines, or the chlorophyll content reduces and the lycopene content increases. You can see this is a turning, this particular turning stage, you can see it turns from green color, that is chlorophyll pigment, or you can say the lycopene pigment dominates the chlorophyll pigments in the turning stage. And we have firmness and our polygalactonous activity. So you can see the firmness decreases. Similarly, the polygalactonous activity, the enzymatic activity increases. It loosens the cell structure, or we can say it breaks down the molecules in the cell wall. It makes it more firm, from firm to soft. And then the pH and titratable acidity. The pH decrease initially during ripening, the pH decreases, and you can see the titratable acidity increases along with the pH. So these are the changes. These are the overall changes, overall biochemical changes take place when the fruits ripen from a green state to a red, mature red state. Okay. Now the water loss. Another important post-harvest problem is water loss. Even when you are bringing it under the cold chain, if it is not maintained under a regular, if the humidity is not maintained at higher humid condition, it loses moisture. And as I said, during heat transfer between the forced air and the commodity, there exists a lot of transpiration or water loss. So water loss is the main cause of deterioration, because it results in direct weight loss, means it reduces. Direct weight loss means it is a loss to the seller or the farmer. Losses in appearance. We won't prefer, if it looks fresh, we prefer from market, right? If it is a shriveled or shrunken fruit, we won't prefer. And then the loss in textural quality. Most of the fresh commodities we consume for its softening and crispiness, like crunchiness. We can say the carrot, if the carrot loses its moisture, it becomes rubbery rather than crunchy. Similarly, the vegetables, sleek or asparagus, we consume for its crunchy biting nature. So if it loses its moisture, it loses its crunchiness. So water loss in case of shriveled apple, the only one post-harvest interventions which is performed very easily control this water loss for longer term cold storage. Apple and all, we store it under cold storage for 6 months, 8 months, even year. In such case, to avoid a faster rate of transpiration or faster moisture loss, we go for a wax coating. So wax coating prevent, even if it is stored under a year under a cold storage, when it is in a cold storage, the temperature is lower, metabolism is reduced, but the thing is, it is continuously under a current of movement of air. So the temperature drops, or the temperature reduce, forced the air is circulated continuously. So to avoid shrinkage, it has to be wax coated. Ways to reduce the water loss after harvest, like lowering the temperature and then higher humidity. Along with the temperature, we have to check the humidity, and humidity holds the key for water loss. Lower temperature, higher relative humidity prevents surface injury. If there is a bruise, or if there is an open area or open wound in the fruits, it accelerates the water loss. So prevent surface injury, application of wax or other coatings, wrapping with a plastic film. So these are some of the post-harvest interventions we recommend for water loss. So pomegranate, you can see the same variety of pomegranate, the gap. This is the initial stage. It shows a sound fruit. After few days, you can see the commodity shrinks. The nature of this pomegranate, you can see the water transpiration will be higher. If it is lined with a plastic bag, we can prevent this water loss. 50% there will be a water loss prevention. You can see the effect of wax and seal packing on weight loss of orange. This is a margarine orange. The first graph shows a control. So this is a control, and we have wax coated and this plastic lining or plastic sealing. So the number of days from up to 90 days or 90 days they have made a study, and you can see the weight loss in control. It reaches almost 80 to 20% of weight loss, 20% of weight loss in case of control sample, whereas wax coated, you can see the weight loss is reduced. Wax coat along with the plastic lining, it reduces below 2%, or you can say almost only 2% of weight loss. So this kind of interventions can reduce water loss. And then now the next problem is physical damage. Physical damage such as due to mechanical harvesting or during transportation, surface injury or bruising, vibrational damage. So these are some of the main possibilities of physical damage in case of fresh commodities. And this is a main contribution for spoilage, microbial spoilage. When there is a physical damage, it easily starts with a microbial spoilage. The damaged area became brown, that is due to enzymatic activity or leakage of phenolic components from the fruits, and it accelerates the water loss from that bruised surface or damaged or injured surface. And again, ethylene production. When there is an injury, it triggers the ethylene production. It enhances the rate of ethylene production and then provide site for pathogen invasion. So the wounded area allows microbial infestation, and then again the healthy fruit doesn't spoil faster. The damaged fruit spoiled faster because it pays a infestation site. It allows infestation, easy infestation for a commodity. So you can see this is a compression bruise, impact bruise in case of apple and orange or cherries. So this particular spot paves a way for infestation, and the spoilage starts from the particular region. And then bruising and skin abscession in case of guava and banana. This is very common. We never get a banana without this brown spot, because it is transported longer under road condition. If it is not properly cushioned, or if there is no proper cushioning material, it leads to abrasion between one over another. It causes skin abscession. So guava is also a commodity which is often get bruised or skin abscession during transportation, and banana. And then we have physiological disorder which caused by improper storage condition, especially when you fail to maintain the temperature exactly towards the particular commodity. It causes chilling injury. In Indian condition, we have multi-commodity storage. We don't have a commodity specific cold storage. We have a common cold storage, and the cold storage person will charge you 10 rupees per kg for 6 months, right? Even if it is apple, we store it. Even if it is a cherry, even if it is a pineapple, we store all the commodities in a single storage. So it's a multi-commodity storage systems. When there is temperature is not specific towards a particular commodity, it leads to chilling injury, freezing injury, and then heat damage. Low humidity changes, low CO2 injury, and high CO2 injury. It's not only, when I say cold storage, it is not only that temperature and related humidity conditions, it is also the gas composition. Okay. So tropical and subtropical fruits are sensitive to low and non-freezing temperature below 15 degrees Celsius. We never store banana in refrigerator, right? It is easy for banana to get chill injury. So the most common symptoms of chilling injury includes surface and internal browning. In banana, obviously, if you store your banana in refrigerator for 2 days, the third day if you make a cross section, the internal browning, you can see internal browning. Even in winter also it is common, but we never notice that we consume banana as such directly. We doesn't make a cross section of banana before eating, right? So we never notice that chilling injury. But if you make a cross section, definitely you will see a brown core in the banana. And then pitting, water soaked area, uneven ripening or failure to ripe. This is very common in banana. In winter, in severe winter, it fails to ripe. It remains hard, even papaya. Most of the tropical fruits, if the temperature is not sufficient, if the temperature is too cold, it doesn't ripe, it fails to ripe. Development of off flavor, and then it increases the decay rate. So these are some of the common chilling injuries in case of fruits, and these are some of the fruits and vegetables tolerant and sensitive to chilling injury. You can see the fruits chilling tolerant. Apple, it is chilling tolerant. Grapes, these things, most of the commodities are the fruits which is cultivated in elevated areas are chilling tolerant, whereas the tropical fruit, avocado, banana, mango, pineapple and sapota, these are some of the guava, jackfruit. These are some of the fruits which are very easy for chilling injury. Chilling injury in case of avocado, you can see the outer it turns black and inner also it turns into black color. In case of avocado, in case of orange, you can see this the burning of this skin. And chilling injury in case of yam and potato is also common. Chilling injury in sweet potato, you can see this water soaked area, water pitting. These are some of the examples for chilling injury in case of sweet potato. And in mango, you can see this rotting of surface near to the stalk. So that's kind of this is a example for chilling injury. In case of apple, you can see the core browning. So it's not ragi, it's a pear fruit. Sorry, peach. It's peach. You can see the chilling injury in case of this is fresh and this is chilling injury. Chilling injury in case of banana. As I said, now this is a chilling injury. In cross section, you can see that brown, the entire inner core became brown in case of banana when it is stored under refrigerated condition. And similar in case of pineapple, the core became brown. And in case of guava, you can see the chilling injuries, it gives a discoloration in case of surface. And freezing injury in case of orange. So orange, when it is stored for a longer period of time under cold storage, now you can see this kind of fibrous fruit. The water gets evaporated, and then once it is freezed and then it get evaporated, it disturbs the cell structure and it aids water loss. Only we have a fibrous core. This is also a problem in case of freezing injury in case of orange. And then we have heat injury, the reverse of this chilling injury. If you are storing it in, you can see this kind of symptoms in case of most of the oranges available in market, because here we have an uninterrupted cold chain. So if it is stored for 6 months in a low temperature, immediately the vendor stack it outside in an open yard, it burns the surface. So this kind of heat injury is also very common in case of interrupted cold chain. So only for one day there may be a power shutdown, or one day there may be a transportation failure, a failure in the temperature maintaining device. So in such case you experience this kind of burn surface. So this is caused by exposure to direct sunlight or excessive high temperature. So symptoms like surface burning, uneven ripening and softening. Okay. So low humidity in the sense that is nothing, desiccation, water loss. So this kind of water loss, fibrous core are some of the example for low humid conditions. Stored under low humidity conditions may enhance the disorders related to desiccation and water loss. And the last thing is pathological breakdown. As I said, when there is a bruised site or when there is an impact site, it paves a way for infestation. So it may be in any botrytis or expansum or rhizophorta, alternaria, phytophthora infestation. So these are some of the pathogenic infestation that are very common in case of post-harvest handling of fresh commodities, especially when you have interrupted cold chain or inefficient cold chain. Now, so these are some of the case study I have to show you the interesting results in extending the shelf life of a commodity. Let us see this effect of temperature and relative humidity in shelf life. In general, the food degradation process increases twofold with every 10-degree increase in the temperature. Okay, the food degradation or spoilage or rate of spoilage double with every 10-degree increase. Okay, a perishable food product with a recommended handling temperature of 0 degrees Celsius will have only 1/3 to 1/2 of its maximum shelf life if it is handled at 10 degrees Celsius. Okay, so if there is a 10-degree increase, it increases twofold the degradation process. In other words, you can say reducing the storage temperature 10 degrees Celsius will double the shelf life of a perishable. Every 10 degrees Celsius less reduction in the storage temperature will double the shelf life. So when the product is stored under 10 degrees Celsius, if the loss per day is 2 to 3% and the relative shelf life is 3 to 50%, if it is stored under 20 degrees Celsius, I am saying that if a particular commodity is recommended to store under 0 degrees Celsius, okay, 0 degrees Celsius, and if it has 100% shelf life, right, loss per day is less than 1%. If it is stored under 10 degrees Celsius, when it is recommended to stored under 0 degrees Celsius, if the storage condition is 10 degrees Celsius, it makes 3% loss per day. We have to bear 3% of loss if you couldn't make it the temperature below 0 degrees Celsius. And again 30 to 55% of shelf life, decrease in the shelf life. And if it is room temperature or above room temperature 40 or 30 degrees Celsius, the shelf life will be only 4 to 5%. The relative shelf life will be only 4 to 5%, and we can expect 20 to 25% of spoilage per day. So this is the relationship between the temperature and relative shelf life and the losses per day. And you can see the temperature and relative humidity of a particular commodity. You can see this is a mass loss of 3 peach cultivars. So the mass loss with respect to increased temperature and increased relative humidity, so lower relative humidity which shows higher mass loss, and then the potential storage life will decrease of Brussels sprouts. You can see the Brussels sprouts decreases when the temperature increases from 5 to 20, 15 or 20, 25 degrees Celsius. Similarly, the asparagus and lettuce, in 0 degrees Celsius it has 20 days shelf life. Again in 5 degrees Celsius it has less than 20, and in 15 degrees Celsius it has only less than 10 days of shelf life. So temperature and relative humidity plays an important role, and this particular graph shows the marketability of the decrease in the marketability of strawberry, asparagus and raspberries with respect to increase delay in cooling. So how much time we delay before bringing into the cold chain. Strawberry, you can see if it is immediately cooled within 0 to 2 hours, it has a higher firmness and then it has higher marketability. And then if you delay cooling, instead of cooling it in 2 hours, if you are cooling it in 12 hours or 8 hours, you can see the marketability reduces from more than 90% to 40%. And the effect of storage on weight loss on storage life of pomegranate. So the same experiment which I shown before, no, the fresh sample after 22 days, when it is stored under high relative humidity and low temperature conditions, it retains the critical parameters like weight loss is low, it reduces the color change, and it reduces the mass loss, and it retains the freshness after 22 days. Okay, the effect of, and then again another commodity, lychee. So this browning, this pericarp browning is very one of the major problem in case of lychee. In northern region of India, we produce large quantity of lychee, and if in southern part, it is very difficult to market to the southern part. We never get lychee, fresh lychee in market because of this pericarp browning. Within 2 days or 3 days, the pericarp turn from red color to brown color. So one of the key to maintain the color is humidification. If it is humidified or if it is stored under high humid or foggy environment, we need to use an atomizer that produce droplets like fine droplets of water, or you can see mist, a dry cloud. It's like a dry cloud which resulted in no depositing of water over on the fruit surface, but the relative humidity will be reaching higher, more than 95%, and the temperature maintaining and below 4 degrees Celsius, which it shows very good results. You can see even after 25 days of storage under 95% relative humidity and 4 degrees Celsius, the pericarp color is maintained, whereas in case of control, you can see it is completely brown or it completely spoiled. And then another important parameters which we have to look into when we are talking about this color change in case of commodity is the water holding capacity of the tissue. If the water holding capacity of the tissue, if the moisture loss occurs or if the water loss occurs, it leads to enzymatic changes or it leads to cell damage. Once the cell structure damaged or the cell integrity damaged, it leads to leaking of phenolic component, and then the color change occurs. So this cell integrity or maintaining the cell integrity is possible, cell structure is possible only under high humid condition. So this browning is due to breakdown of cellular component. Moisture is important for maintenance of the cell structure of lychee. High humidity, we maintain the cell structure of the lychee. The weight loss is higher in control sample, which leads to loss of membrane integrity. So this membrane, once the membrane integrity is lost, it leads to phenolic ooze out of phenolic component, and the pericarp turns brown color. However, only slight weight loss is occurred in case of commodity stored under humidified condition. Okay, and this is another results which shows the effect of pre-cooling treatment on respiration rate of grapes. So you can see the respiration rate of grapes remains under low rate when it is immediately pre-cooled, and this is the treatment, like pre-cooled immediately after harvest, and then the last one is pre-cooled or directly brought to cold storage after 12 hours of harvest. So you can see the difference in these treatments. So immediately, if it is cooled within the 4 hours, you can see the one of the important problem associated with this green grapes is turning off this vein into this green color vein to brown. So the freshness of the grapes we can identify only with this vein color. If it remains green, it is immediately harvested, or it is harvested fresh. Within 4-5 days, this particular vein discoloration starts. So to avoid this vein discoloration, pre-cooling and low temperature, high humidity storage is recommended. So without harvest, like even during 40th day of storage, you can see it is completely spoiled if it is immediately bought, if it is bought directly to the cold storage without pre-cooling after 12 hours. Means within that 12 hours of time, the ethylene production would have started, right? And then it is of no use even bringing the lower temperature, still the metabolic activity continues in the slower rate. Okay, and then effect of pre-cooling in case of lettuce, you can see the commodity, the respiration rate remains lower for 20 days if it is harvested. So only there is a small increase in the respiration rate. Okay, so this is the lettuce. You can see comparison of different pre-cooled lettuce. 20 days, even 20 days of storage, the lettuce, the leafy lettuce which turns only the first few layers are color changes, like remains it's fresh, whereas it's completely spoiled in case of without pre-cooling or without pre-cooling if it is stored under refrigeration. So you can see this kind of water loss and the shrinkage occurs faster when there is no pre-cooling or proper cold chain is maintained. So spoilage of lettuce after 20th days of storage reaches 98.6%, means it is completely spoiled. 98.6% spoiled means completely spoiled, whereas the sample pre-cooled has only 10.3% spoilage. The next thing is cold chain management gadgets. I will try to finish it faster. So there are some cold chain management gadgets from harvesting. During harvesting we have as I said, pre-coolers, forced air pre-cooling, hydro pre-cooling systems, and we have food processing plant or pack houses, some of the cold chain gadgets required at the harvesting site. During transportation we have refrigerated trucks, refrigerated cargoes, insulated shipping containers, cold storage facilities. In retail shops we have display cabinets, beverage and this closed open refrigerated racks, and in consumer side we have freezers, refrigerators, high performance coolers, and commercially we have walk-in cold room or cold storage, refrigerated cabinets. These are some of the cold chain gadgets which connects different operations in a cold chain. So these are the freezers, display cabinets, and visibility coolers. And this is another interesting study which shows conversion of this domestic air conditioners into cold storage rooms. So cold bolt is a technology which makes some changes in the refrigerant cycle, or it allows it makes some changes in the expansion valve. When you changes the expansion valve, the rate of cooling or the cooling load in a air conditioning system can be varied, and it can also be used for cold storage, domestic cold storage. You can see in a field study it shows 6 metric tons capacity a farm level cold storage reduces 30% losses to 5% losses. You can imagine the quantity of product they have saved. From 30% the losses is reduced to 5%. So these are some of the advanced reefer containers available in the markets for shipping fresh commodities across the globe. It has a refrigeration system to maintain the temperature and a humidification system, as well as it has gas sensors. So it continuously monitors the gas level inside, and it send signals to the receivers, to the company people, or else it makes corrective actions by automatic decision. It flush gas inside the chamber, it reduces the temperature, it flush it automatically switch on or switch off the humidification system. So this kind of advanced reefer containers are now available for transportation of fresh commodities with gas sensors, with temperature, related humidity sensors and actuators. And this is one of the Indian startup, Perishable. This is one of the plug chill mechanism. So in this reefer container we need a separate dedicated refrigeration unit. So there should be a refrigeration cycle, and the refrigeration cycle should run continuously to maintain the temperature, whereas this is for domestic market or domestic supply. It has a thermofluid, it has a circulation of thermofluid. The temperature of the thermofluid is reduced initially by plugging. When the vehicle is standing in the night time, if it is plugged to electric current, it has a refrigeration system, it operates the refrigeration system, and it reduces the temperature of the thermofluid. and then during daytime, if it is the plug is removed, the temperature can be maintained for more than 5 hours, and 24 hours temperature stability. If the temperature is stayed for 24 hours, the low temperature is maintained. So this kind of plug chill mechanism, which has 60% lower operation cost, right? So these are some of other kind of alternatives for refrigerated vehicles or reefer containers. Now, new technologies in cold chain management systems for perishable commodities. As I said, this warehouse software management systems, where it collects data from each and every point of the warehouse operation, and it makes it store it with the help of IoT device and blockchain technology. The informations are secured, and the corrective actions are decided by itself, by AI. The corrective actions are decided, and the food traceability system, this is also coming up with blockchain technology. Each and every stage of harvesting and distribution site, the data are collected and secured with the blockchain technology, which ensures the traceability of the complete traceability of the fresh commodity. Thermochromic ink, which shows the temperature and relative humidity conditions where it is stored during the transportation. And photocatalytic dye, which is UV assisted photocatalytic dye degradation techniques, which shows whether it is stored in a open yard or a open shipping yard. So this kind of photochromatic ink and thermochromatic inks helps us to trace the temperature history the products came across. And we have modified atmospheric packaging, you may be knowing all those things. Dynamic racking system with help of AML, dynamic racking. Which commodity comes first in a warehouse? Which commodity should go first out for retailing, right? And then portable TA tent, CA tent. So this kind of reefer containers, or within the reefer containers, portable CA controlled atmospheric conditions can also help us in increasing the quality of the commodities. And then multi-modal transport and PLC automation systems, ensuring the safety of temperature and humidity conditions. Alternate cooling. Apart from this refrigeration system, vapor compression refrigeration system, we can go for vapor absorption refrigeration system, and then magnetic leviation refrigeration systems. So thermal banks. So these are some of the concepts which is growing on recently in alternating the alternate cooling solutions for the fresh commodity. And various hybrid applications of energy sourcing, solar based energy, thermal based energy, wind energy from ship during transportation, energy from the ocean itself. So there are some of the alternate energy concepts also coming into the cold chain management. Now IoT and blockchain technology for cold chain. So the use of Internet of Things in cold chain, already we have sensors, temperature sensors, humidity sensors, gas sensors, and we have actuators which can receive the signals from various sensors, wireless communication devices which shows from remote place we can operate what is the condition of temperature, what is the condition of the gas composition inside a particular silo or a particular reefer container. So all those things are already in market, and there are some softwares. So this wireless sensors, right from the farm till transportation, distribution in supermarket, RFID tag, it may be an RFID tag or a barcode sensor, or it may be any kind of gas sensor with wireless networking. Gas sensor, temperature sensor, pH sensor, which is connected to a wireless networking device. So whatever data we are sensing, and then the data will be collected, and it is secured to a data secure system, and then it is made available whenever it is necessary. That kind of blockchain technology with the help of IoT devices are coming up. Temperature monitoring during the entire transportation, shipping tracking, increased efficiency and productivity in case of logistics, reduced operational cost, reduced in spoilage of goods, real-time data we have access to the real-time quality parameters of transported commodity, real-time data access, automated report generation. So these are some of the plus points in case of blockchain technology. So farmers, as a farmers, they can have a data. Producers or a processor, they will have a data which they require. Distributor, retailer, and end consumer will have access to all the data. Whatever data which is fed into this blockchain, they will have a secure data which shows where from which animal it is the milk is taken, or from which tree the fruit is taken, and what is the condition of the tree right now. When you are consuming, we will have a data about the tree from where it is grown and what is the condition of the tree now. So in such a level, these traceabilities are possible with the help of blockchain, and these are the advantage: the transparency, tamper proof, cost efficient, and then the advantage and limitation of this blockchain technology. And this holistic collection of storage of data and information. This Emerson company provide software solutions where we can feed data during harvesting, processing, transportation, and distribution, and it will be made available in a cloud storage. It can be accessible by any end users at any period of time. Listed, this is also another company which provides the software solutions, right from smart farming, semi-automated farming, traditional farming. What are the farming practices? The data related to the farming practices, data related to the pesticide given, data related to the irrigation, when it is irrigated, when the pesticide is given, when the pre-harvest spray, when the post-harvest spray is given to the particular crop. Right from there, tracking the cold chain, from how many days it is transported, how many under what temperature it is transported, and then the traceability of the cold chain connected to distribution centers. So all those things is possible by end consumer can analyze all the data, can have access to all the data in this kind of blockchain supported supply system. So this is Source Trace. So this is one of the company which provide tracing solutions to the agriculture commodity, especially in case of minimizing this aflatoxin problem or pesticide related problems. The Source Trace has lot of advantage and lot of data collection point and data reliable points. So remote cold supply chain management. So from a remote place, a company, an exporter can have a look on his product, its quality, storage temperature, whether it is ripened, whether it is half ripened, whether it requires any interventions. So all those things can be decided from a remote places. That is what the modern cold chain systems are approaching. So as I said, this Emerson and SenseMate. SenseMate is also another software solutions which provides end-to-end data collections and distribution sites. Okay, thank you.